Xe F4.
Okay, so
Xe F4.
xenon and fluoride. 4. 8. X4. I'm trying to find out
Xe.
Good. Okay, find the you find out the atoms. Their atoms. It's xenon.
Yeah, how many electrons? 8 valence. 8 valence? Wait, no, I need electron. Oh yeah, valence. Sorry, so 8 valence.
Okay. 8 valence. It's a noble gas. Wait.
Yeah.
It's a so it can do it.
Oh, you can. The chemists at the University of British Columbia won a Nobel Prize because they made a compound with a Nobel gas. That was one of them.
Oh.
Yeah.
Alright, so wait,
So it's an exception.
then how much? Then it doesn't have electrons to bond it.
Pardon?
Because the last one.
Oh, they have electrons.
They have electrons.
They have what's the central atom?
Xenon.
Xenon. There you go. It's irritating, isn't it?
So do we like take electrons from the
Oh, I'm not going to tell you how to do it. You got to grab a partner and go try.
because fluorine has 7. Fluorine has 7. Yeah.
Alexander?
Here.
Aria? Ariel?
Here.
Charlie? Ching Chao? Eric? Guy? Isaac?
6 times.
Isabel?
6 times.
Jessica?
That's
Katie? Fiona?
Are you sure?
Fiona? None.
Hold on. 20.
Yes. And there's more up front too. Natsuho? Sihu? Sterling?
Each one has a double
Sterling?
bond or just one?
No Sterling. Oh, right. Never mind.
Let's try 2. I think 2. The math works if 2 of them.
Jaden? Tom? Tyler?
6 times 2.
We are just missing Fiona. Okay. I'm not answering any questions. You can ask anybody, any groups. It does bond. University of British Columbia chemists won a Nobel Prize for bonding a noble gas. This is one of them.
It's bonding.
It's bonding. It is that. It's not a trick. It really is a compound.
Maybe.
Because only 4 on
Well, there is a
4 times
trick.
4 is 8. Sorry, 4 times 2 is 8. Then 8, and then 6 times 2 is 12. So 12 plus 8 it does not equal 24, right? So we need.
So maybe one bond.
I think
One double bond.
I think all of them have double bonds.
No, but this has way too many bonds. Way too many.
Okay, so we can only have 8. So that no won't work.
Maybe.
How are other people? They all have 4 extra. Jaden, xenon can't have that many in the valence. Yeah, we have 4 extra as well. We have to configure them differently. So
Draw the. Draw the fluorine around.
wow. No, we know it can't be that way though.
But that's what we need to do. Draw the F.
You don't know that it's like that, and that doesn't work anyway. Even if we use double bonds or triple bonds.
Oh, wait.
So we need a different configuration, which could be. We need a different configuration.
Wait, are they doing a charge? They're doing something. Oh,
Once you believe you found your answer, you can have a seat.
Do we give it a try?
Mr. Ufo, can we give it a charge?
Pardon?
Can we give it a charge?
Does it have a charge?
So
No charge.
okay, so we can't give it a charge. Those are wrong. 4F8. So we need to configure it differently. So where should the xenon be?
I'm very confused.
Oh, nice to meet you. Very confused. I'm Mr. Newfield.
I asked him, he said which one is the.
yeah.
Minus 8.
Yeah. Yeah.
Minus 28.
Yeah.
All those.
Well, minus it, show me, and then look where you. So how many did you put on there?
This is 26.
Are you sure?
2, 4, 6, 12. Yeah, 24.
24 makes sense. Because 6 times 4 is 24. So minus 4, and then yeah, you got to figure out what to do with the last 4 electrons. I'm going to tell you what to do. When you go with your best diagram. I'm not saying anything. I'm just going to put down what you think the best answer is. Well, I'm not telling you until we're done. Once you think you've got yours, have a seat.
10, 12, 14, 16, 18, 20.
I'm gonna just say like
Maybe. We'll see.
Further down.
We'll see.
12, 14, what? No, I'm not helping. Dude, come on. I'm not helping.
what do I do once a week?
Got it, bro.
You do you, bro. Actually, what do I do once a week? Oh, you guys got the same thing, right?
Yeah.
It feels wrong. Look, what are these bonds doing? These are giving 2 to this, and then there's
Okay, most people seem to be done, so I'm going to give you 10 more seconds. 9, 8, 7, 6, 5,
Let's go.
4,
Let's just go.
3, 2, 1, 0. Okay, any, can I, was this your work? Can I have your final result? Any other final results? Is that just rough work?
Yeah.
Rough work? Yep.
That's not correct.
What do you mean it's not correct? Ugh, well, it's creative, that's for sure. Okay, let's see what we did. Now, obviously, there is a right answer because people have seen the structure. It wasn't entirely fair because I gave you a bunch of rules, and then in this case, the only way you can win is by breaking the rules, much like the Kobayashi Maru. So looking at this one, I'm assuming these are like not on the bond?
No.
No. So, good. Same conclusion? Good. Put it on the bond? Yes.
You broke the rules.
Um,
Because Xenon is so far down, the offset rule is
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, so this one, your error is that I did tell you that you there's only one central atom. There is no chains. You don't have to worry about that. However, to get the right answer, you had to break a rule. You broke a rule. It was the wrong rule, but you had no way of knowing that. That is a very clever solution. And if you also didn't know, like you're a real researcher, you don't know how it works, that would be a possible thing you'd have to investigate. We just happen to know now it doesn't do that. So it's one central atom, they are all around. That was clever. The fact that it has all the right number of electrons and they all have an octet, that's fantastic. I like this, because you just straight up said, charge of 0? No, I'm gonna make a charge of 4. Those electrons don't exist, and you got rid of them, and you changed the charge, which was clever. It doesn't have a charge. So that's not just breaking a rule, you just ignored the question, which, that's also a clever thing to do. They all have an octet, it's good, it's not right, but it is good. Similar, same one, you took away 4 electrons, broke what you were supposed to do, which is good, it just happened to be wrong. So it was just a question of, did you break it in the right way? By the way, this makes a 3-dimensional structure. You have xenon in the middle, and the actual structure is that fluorine would come out like this, and then those lone pairs are sort of like lobes here of negative charge, and a lobe there of negative charge, and so these fluorines, like this bond is coming straight out at you from the board, and this one's going away, so it actually would make a square, a flat square with the electrons on top and bottom, trying to get as far from each other as possible. So it does do that. The secret is, of course, when you get into the big atoms like xenon and phosphorus and things, they can just break the octet rule because they have those inner d electrons and they can just start doing stuff. So the secret was in one of the methods I gave you, let's say we did it xenon, 4 fluorines. Xenon has how many electrons? 8. So it doesn't have the d electrons there. 4 7s are 28. What? Yeah, 28. So we had a total of 36. You put in your central atom, you put on the outer atoms. So we got 36, 2, 4, 6, 8. Put on our octet. Now, we always start with the outside, and we give them a full octet. That is minus 4 times 6 is 24. And then you know the 4 electrons. A lot of you are there like, what do I do? The last step in the accounting model is you take all the extra electrons and you put them on the central atom. And I noticed you did want to put it in the coordinates, but now we have the coordinates of up and down, which are hard to represent on a traditional board. So yeah, that is the correct structure. You're allowed to break it for big things. So, not terribly fair. Yes? Let's see what you can do with. These ones then shouldn't present too much difficulty. And so, but now let's mix up those pairings. You got a little comfortable. No, I don't want that one. I want where'd Class Dojo go? Class Dojo and in, and we are block B. And I already took attendance, so we have one person ready to quiz. So whoever has that for a partner, I think there's an extra person. So Guy, just go with who's ever missing a partner. Grab your new person, erase what's on the board, try those 3. Pardon?
Where's my thing?
Guy. Okay, go. Go. Find your partner so I can get this up and I can show you what the actual work is. Who's by themselves?
Dude. Where's my periodic table?
Oh, I love that Aria and Ariel are together. Yep, I'll put it back up.
Bro, where's my periodic?
PCL5, SF6, and BF3.
Bro, where's my P table?
Wait, so we're doing all 3 of those?
All 3.
I love that.
This is beautiful.
I love science actually.
Science is fantastic.
Phosphorus, chlorine,
It's like breaking.
You can break the rules for atoms that are big.
I'll bring mine.
Okay.
Right.
So for phosphorus, chlorine 5. Yeah, 7 times 5 is 35.
So, phosphorus. Are you doing the accounting?
Any chains or something, right?
Pardon?
There aren't any chains.
No chains. Everything bonded to a central atom.
7 times 5 is 13.
Oh, where is phosphorus? Where?
Can it have?
This is the first one.
But that wouldn't that put
This is the third.
like 10 electrons? No, that means I create a new shell, so we'll probably have to put
Yeah.
5 to 6. Yeah, we have to put 6.
You've got numbers of electrons, things you can figure it out.
So 5, 10, 30. So 30, and then 6. So Then those are 2. Those are 2, and then we need 6 times. What's the?
I think 6 in chlorine is right?
Yeah, wait. 4. We need 30 for that.
How much do we have? 24?
Yeah.
Wait, is that a 2 or 24?
24.
And then including these?
Yeah.
Maybe get rid of these for now.
Oh, wait. I'm thinking we hit the.
Or does the chlorine maybe bond to another chlorine?
I'm thinking we do this, and then that's 12, and then
Yeah, but then we still won't have enough.
no, we still
Oh,
have
if we
24.
double bond all of them?
Wait, no, and then oh, we could do that, but like wait, so that's 4, 4, 6. No, okay.
Sulfur? Bro, why did I make it so big? Yeah, so we could double bond all of them, and then that's.
Double bond, so
that's
10,
20.
10, 20, yeah.
And then we'll have 20 left over for. So just, yeah.
Alright. Oh, okay, that's it.
And then how much? Only 4, and then 4 times 5 is 20. Yeah, that's it.
No, hey, you don't erase my work. So you're the one who does this, bro. I never did this.
Yeah.
You want to do the last one?
Mine's 10.
Oh, he does.
Yeah. And
The only problem is that phosphorus has 10, sorry guys, 40 electrons in its outer shell. But that, he said it's
What did they do for this?
40 protons.
I do not.
Wait, phosphorus?
Boron.
I mean electrons.
Boron. Boron.
Well, we'll find out, I guess.
no, since it's double bonded on all of it, and then
Yeah, but these count as 4, right? And 4 times 5.
then
Oh,
I
wait,
do
sorry,
this.
not 40.
I would do this.
20.
Have
One electron.
and then what's that equal to?
But then it doesn't have a full outer shell.
Wait, no, wait. Let me.
I think we'll just see what he says if we leave that as double bond.
Okay, once you think you've solved all 3,
We'll just
you can have a
leave
seat.
it we'll just leave it as it was and find out whether
And I am going to go back and put in the answers that we're missing. Because we did them on the board.
Think about it. We're gonna do that, and then
What else do we have?
6 here instead. 2, 4. Because now since there's 2, 4, 6, 8, 10. Wait, 2, 4, 6.
I guess 9. Does the 6 work out? Like for the phosphorus?
Oops.
phosphorus and chlorine.
Yes.
If we did it on a small whiteboard, do we put it on the board?
Oh yeah. Wait, why doesn't wait,
Yes,
that might
if you
work
could put
out.
it there, that'd be
I
fantastic.
think it works if you just do single. Single bonds. That works. The phosphorus does work. Yeah.
No,
it
this
works.
works. This works.
No, the single bonds work better.
No, because this gives phosphorus a full valence shell because it's 16. It's 16, and then that makes another shell with 8 phosphorus.
Wait, how does I have 16?
1, 2, 4, 6, 8, 10, 12, 14, 16. Because one valence shell is 8, right? And then because 16 it would be another valence shell. It would create another shell. Yo,
Okay.
what's the? I think. Yeah, I think I'm.
think you're right.
No, because boron needs to have 8. It still follows the other. Wait, which one here? Oh. So yeah, my answer was wrong.
I think this is the correct.
How the hell?
No, but if it's 16 electrons, it like 16 because there's 8 bonds. Wait, yeah, 8 times 2 is 16, so it would create another. Wait,
Why is the it's like phosphorus?
yeah, the roster.
Yeah. Man has the little queuing up.
For the first one, I don't think you have. No, for the second, yeah.
There we go.
For the first one, you do though.
You break down that 12 for the phosphorus.
No, that gives 16, so it creates another shell.
Think about it. Jaden, bro, I think you're okay.
Think about it.
Ooh, we got some good work going on.
Since I gave it
Doing
8
the German way now.
bonds, so that's 16, and then it's 8 per shell, so then it creates
But
another
can't
shell.
electrons only
Yeah,
bond
the
if
bond
there's a
only
valence
with the-
shell?
Are we still breaking rules?
I don't know,
Do you-
bro. I'm a break rules.
You're a rule breaker?
No, that makes me sore.
Yeah.
Oh, hell no. I'm such a good boy.
Why are we still about 40 minutes in
I'll
this?
put it on your table.
I thought we had a test.
However, I miss it. Yeah.
Dang it.
Oh, wait, bro, I thought we had a test.
Test them.
Apparently we do.
How many electrons do your fluorine have? No, you have none of them. There you go.
It's only 3
I
days.
locked in for the test.
Okay. Fancy stuff. Go. Is that on?
Obviously, you're obviously. But it's still fun.
You do it?
Wait, I might be wrong.
No, I think you're today, bro. I don't even know at this point you do it.
Because
They're gonna
now that I think about it, they're supposed to only bond on like a valence shell.
No.
This creates a new shell.
Just that chance. Like, hey, bro, I'm cooked. We're gonna make concussion.
Okay, pay attention. We'll go through them. I think I'll do one at a time. PCL5.
I'm a heavy hitter.
PCL5 breaks it straightforward. Good.
Okay.
Good. PCL5 just breaks it. Good. So this one is you just put in a bond. PCL5. PCL5. And then something happened. Is that bond going to that bond? Or going to that chlorine and then going to that chlorine? It's everything's on a central atom, so actually we have to put it there. Give its electrons back. Because phosphorus really does break it. There is no chains in this particular one. And for sulfur, it's the exact same one, except you have 6 of them. So sulfur can break it 1, 2, 3, 4. Holy. SF6. Oh, I like this. You made it SF5 and just shoved someone out and voted them off the island. You're not allowed to be a part of us. You're not good enough. But SF6, if you work out the electrons, there's 6 of them. There's 36 electrons after you do the bonding. That fits them all for an octet. And sulfur is one of those fancy ones that's big enough and has access to extra orbitals that it can do that. So if you just put the S in the middle, put all the fluorines on, it's actually very happy. These are good. These are good. Sorry, I'm looking at your boron, but we're not there yet. And all of those were just to lead you down the garden path. Because then my real curiosity is, what are you going to do with BF3? Which one's unhappy here? No one's really unhappy. Sort of. However, this is not the structure. And where's it here? Yeah. We have a double bond there. That is not the structure. And that is not the structure. That is not the structure. And this one, that is not the structure. Is everybody happy in those ones? Like, did they make the octet row? Yeah. And do they use up the proper number of electrons? Yeah, they do. Because those all have 7, and you end up with 3. But the actual structure for BF3 looks like this. New page. I don't want to fix that. So how many valence electrons does boron have? 3. And then we got 3 fluorines, which is 21. So we got 24. So we got boron, we got fluorine, we got fluorine, we got fluorine. We go 1, 2, 3. 2, 4, 6 minus 6 gives us 18. That is just enough to give it, and then you very cleverly put that on there, and that fixed the problem. Except boron is an exception, and it only does 6 electrons. It has the hextet rule, and there's no way you could have known that. So you all did a very good job with what I told you, but boron, unlike the other ones that were too big, it's too small, and it just can't fit it on. So boron is like hydrogen. How many electrons does hydrogen want in its outer orbital? 2. Boron wants 6. And that is not fair, and something I am not going to test you on. This will not be on your quiz next week. All of these are just extras, but I might include a bonus one that could like bonus it. But it won't be on the standard quiz. We're going to go only this far. Yep.
Is there a quiz today?
Yes. There's a quiz every week just to check in and see how you do. Where? There it is. Now we're just going to start this. The fumes weren't quite ready this morning. I think they are now getting ready to go. So next day we're actually going to have some demos, and I will show you the chemical reactions I'm only going to mention.
What's the magic word?
Pretty please.
Bro, I'm just kidding.
Say please, Daddy.
That would have been even more zesty.
Please and thank you.
And periodic tables are. Anybody else need a periodic table? Sure.
Better not be common.
Is this a quiz?
Is that not?
Morals and values.
Is that not part of your morals and values? You're a morally sound guy.
I am a morally sound guy.
Okay. A chemical reaction,
do
obviously.
You're not gonna be a morally sound guy.
Is a chemical change. How do we know when we see a chemical change? What's the difference? What's an example of a physical change?
Nothing.
Nothing?
Nothing.
Melting. Melting is a good example of physical change. How can we tell the difference between melting and reacting? Yes?
Melting is just like the physical features change, and reacting is like the atomic structure change.
We can't see the atomic structure, though.
It makes a new substance.
Makes a new substance. So, yeah. How could we tell?
Odor, color.
Odor?
Odor, color, temperature.
So we have odor. So a new smell is given off. I'm also going to put texture there because someone mentioned that and I was like, I never thought of that before, but yes, something can actually feel different. Odor, texture changes. And then you quickly said change in temperature, which is a whole different thing. Because a change in temperature is also a classification of a whole different type of, oh, do you know what a square triangle means?
What?
Change. Should probably write that out. I get used to doing that from formulas because it means change, but change. If it's changing temperature, what's changing?
The energy levels?
Yeah. So this is a type of change in energy.
That's true. I forgot.
What else changes? When you have a change in energy, what kind of energy could you observe? Yeah. Give me an example of a property that you might observe. It might help to think of a chemical reaction you might be familiar with. But if we have a change in, okay, something blows up, change in temperature, what else do you observe? What other changes in energy?
Kinetic energy.
Kinetic energy. So you can get kinetic energy. It can literally explode towards you. What else might you observe?
Light.
Light.
So what, photons?
And a horrendous sound. So, sound. All these types of energy can be given off, theoretically, bolts of electricity, depending on the speed at which things happen. So you can get quite a change in energy that happens in a reaction. Now, this is energy change in temperature. This is assuming this is not just a change in temperature. You're going to be really annoyed. I'm erasing that word. Increasing.
Aren't there endothermic?
There are. What would that observe?
Like less than temperature? Like it gives out energy?
It doesn't give
Yeah,
out.
like it
Decreasing temperature.
Yeah. Yeah.
Now, we don't often observe a decreasing temperature. I'm going to show you a reaction where it actually gets colder. In the same way, an exothermic reaction gets hotter. But if you have an endothermic reaction, it's not that it gets colder normally. It normally just doesn't go unless you do something to it. What do you have to do it?
Shake it like.
Yeah, that could work. There's a more common way. Yeah. No, all right. Pardon?
It's something else. I have a question.
Oh, question, yes.
If it's like a change, if it's like decreasing temperatures like a change as well, wouldn't like water freezing be a chemical change now?
That's a really good point. These are not rules, they're clues. So, for example, one that people frequently give, because you learn it in junior grades, is difficult to reverse. And if I took your test and I burned it, could you reverse that? No, it'd be you'd have to capture the carbon, you'd have to feed it to a plant who would turn it back into like an actual fibers and remake the paper, like it'd be a huge deal. However, if I took your test and I just put it in water and I dissolved it and I mushed it around, would that be easy to reverse?
I mean, alright, if you didn't rip it.
Oh, no, mush it. Like, turn it into pulp. The ink's still there. It's just dissolved. That might be a little harder. If I just took your test and, like, shredded it, and then took the shreds and shredded it sideways, you can make a physical process be difficult to reverse. There's also some chemical reactions that are easy to reverse. We can take water, apply electricity, and get hydrogen oxygen gas. And if I take that hydrogen oxygen gas and I put it into a balloon, and I light it, what happens?
Water.
You make water. So some chemical reactions go back and forth. All of these are clues. So there are some things. Odor and texture changes. Ice is very different from water. And so that will be a clue. But the more clues you have, and the more the properties change, the more likely it is to be a chemical change. Sometimes it's really hard to just figure out which is which. It reminds me a bit of the definitions biology gives for what is life. And if you count up all the definitions for what is life, does it excrete, does it move, does it take in energy, does it have a metabolism, and you apply them to a chemical reaction like fire, it meets like 8 out of 9 of them. The only thing it doesn't do basically is evolve. So they're only clues, these aren't rules. You can find exceptions for every single one. But now it's time for your quiz, so put everything away, get your periodic table, calculator, if you want one. Move your tables around, sit in other places. When I call your name, please come up and grab this piece of paper. Alexander. Tom. Eric. Joe. You were faster than the first name, so there. And that's Alexander's. Arya.
What's an aisle? Me neither, but it's not that deep. This is science, bro. Like the same year. This is like year 6 science, bro.
Arya. Oh, sorry. Ariel.
This is year 6 science. It's called
Tyler. See who? Jing Shou. Oh, there it is. Isabel. And you're now allowed to go.
Tell me to wear it.
Yep. Hayden. Jaden. Jessica. Natsuho. Isaac. Charlie.
Oh hell, bro uses brave. He uses brave.
And Fiona.
Mr. Neufeld uses brave.
Use what's it
Yo,
called?
you're right in front of the mic, Jim. What do you got to say?
For browsing? For browsing?
Oh wait, no, what are you talking about?
I'm talking about
And while you're waiting
browsing.
as I hand out the test, if you could take out your worksheets and put them out, the ones that look like this. Make sure your name is on them. I will be collecting them as I hand out your test. Yeah, you left it behind, so I do have it.
Oh, I made a number of things.
Wait, did I give you mine?
I want to buy one.
I'm going to come around and grab it.
Oh, did I give it to you like last time?
No, other than Ariel, nobody else left it behind. I didn't ask for it either.
I made a new one because I thought I forgot it.
Oh, okay.
What?
Yeah. And not okay, as I come around, put away your binders,
Yes, draw the
worksheet should be on there, everything else, nothing
Draw
you
the
don't
full
need for the
valence
quiz.
shell.
On the quiz, on your data sheet, it has your name, it has your student ID, it doesn't have the title of the quiz, so give it an appropriate title, there's a big long title here, and circle and color in the version number. You will have a different version from your neighbors, so make sure you put that in correctly. You can start as soon as you get it. Oh, and I need to grab, and your worksheet. Your worksheet.
Oh, yeah. Thank you. Wait, do you want my worksheet?
Yep.